All right, today is going to look like some review because we have already talked through some of this as we got our introduction to writing equations. You guys wrote some basic equations on your quiz. So the formatting that you see up there is not changing. None of that is changing. We're going to make it a little more complex because as you've noticed over time, sometimes you look at a curve and we just drew it ourselves and it was a cosine curve, but when you got done and you step back, you're like, that looks like a sine curve. That's because you can write every single one of them as both. They can all be written as a sine curve and a cosine curve based on how you pick the phase shift. But in this, A, B, and D will never change as you write your equations. It doesn't matter if we shift it pi to the right or pi over 4 to the left or write it as a sine or a cosine. Those three numbers are consistent for every equation about a picture that you can write. The ones that will change, first of all, which function you pick to write it as, and the phase shift, and those are related to each other because where we start it will matter which function you're writing it as. Okay, so as we move from the different equations of the same picture, C is the only thing that'll change from equation to equation. Okay, so like I said, the beginning part of this is a bit of review. It's hopefully should sound familiar. So how do we attack looking at a picture and writing the equation? The first thing I would say is find your midline. Where's your maximum? Where's your minimum? Where's exactly halfway between that? If that's been something that's not been super easy for you, one of the strategies you can use to find the location of your midline is just count. Count from the absolute lowest point in your graph to the absolute highest point in your graph. That distance right there, I would consider the total distance of your graph, right? So ours goes from -5 up to 1. If I were to sit there and count that, our total distance would be 6. So how do we then figure out our amplitude and our midline from that if that's something you've been having a hard time with? Well, your amplitude comes from half of that number. Okay, well, if our total distance is 6, our amplitude is 3. And then our midline, again, it's splitting our graph exactly in half. And that distance that we just figured out, 3, that's how far our midline is from the bottom or how far our midline is from the top. So if I were to count down 3 from the top, we see that we would draw a midline at -2. The location of the midline is the D value. And once I have those set, once I have figured out A and D, just like I put on the first page, those are the same for all equations that we will write about that picture. Whether I write this as a sine or a cosine, it does not matter. Those do not change. The other thing that will not change is the period. And I know that this next part is not in your notes, but looking at this, how do we figure out the period of a graph? Okay. Well, my strong suggestion to you is as we are trying to figure out the period of the graph, start at the y-axis if you can. And I'm going to show you one where you can't. But start at the y-axis. Right here, you see that we have a sine curve starting at our y-axis. To complete one full sine curve, you have to hit these requirements. You have to hit a maximum, you have to hit a minimum, and you have to get back to the midline. So those things have to happen in order for you to complete one full sine curve. The order, so the period on this would be considered 2 pi. The order that those happen in does not matter. So I could hit the minimum first. Like you see on this one, starting at my y-axis, I would hit a minimum first, hit a maximum, and then get back to my midline. The order that I hit that min and max does not matter as long as I hit one and get back to my midline. Got it? Same thing on this one, period of 2 pi. I didn't make those weird or anything, just 2 pi. If at my y-axis I'm looking at a max or a min, we're counting a cosine curve. So what does it take me to complete one cosine curve? If I start at a maximum, I need to return to a maximum. How long does it take me to get back to a maximum? That is the period. If I were to start at a minimum, I need to return to a minimum to finish one cosine curve. And again, that would be the period of the graph. So it's either a max to a max or a min to a min. Okay. Now, it doesn't matter what you're writing it as, sine, cosine, whatever. I counted a sine curve and I go to write my cosine curve, doesn't change the b value. Once we figured it out for that picture, that is it for the entire picture. So on the rare cases where we don't actually start our graph at the y-axis, let me give you an example of what I'm talking about here. What if we don't have a curve that's actually starting at the y-axis? Do you guys see what I'm talking about in this picture? It's not at a maximum, it's not at a minimum, and it's not at my midline at the y-axis. You see that? You have to count then either a sine curve or a cosine curve. You got to adjust a little bit for the fact that you're not starting at 0. Okay? So I could count starting, like if I wanted to count a sine curve or maybe a cosine curve, but a sine curve here, okay, well, how long does it take me to complete? I would have to hit a maximum, I would have to hit a minimum, and I would have to get back to my midline. That means I started halfway between there, so at pi over 4, and I ended, so this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, 8, 9 pi over 4. The period is the difference between those, or how long I actually moved. From pi over 4 to 9 pi over 4 would be a difference of 2 pi, 8 pi over 4, right? So sometimes you just actually have to spend the time and count on the graph. If it doesn't start at 0, it's not going to be where you stop if you didn't start at 0. Okay? Doesn't happen often, but in those rare cases where it does. All right. So let's go back to the example we were working on. Let's find the period of this one. Based on how this one starts at the y-axis, I would count this as a sine curve. Agreed? Y-axis. Trace at the y-axis till we hit our graph. That's at a midline. So I'm going to count it like a sine curve, which means I have to hit a maximum, I have to hit a minimum, and I have to get back to the midline. When I do that, that number right there is the period, which is pi in this case. The number we put in our equation, 2 pi divided by that. So 2 pi divided by, put pi in there. This is the number that goes in our equation. This is the number we see in the graph, right? Difference between period and b. And again, this is the same for all equations. Doesn't matter if I now decide to write this as a cosine curve instead of a sine. All of them will have a b value of 2. So then as we go to put all this together on this page, A won't change, which was 3. B, we just figured out, won't change. D won't change. All that can change from each of my individual equations is our C value. What I would encourage you to do is always write one of them, because most of the time you can, without a phase shift. So I could have absolutely handed this to you on your quiz, and this looks a lot like one of them that was on our quiz, right? Where if I were to start my graph at the y-axis, it would be this dot right here, which means what is our C value if we start at the y-axis? What's our phase shift? 0, right? We're not moving right or left. I'm starting at the y-axis. I don't have a phase shift on this one. So we could write this as y equals 3 sine, because I'm starting at the midline. And then we have a b value of 2. We don't have a c value, so I don't need parentheses, minus 2. If you choose to always put the parentheses in there, that's fine. Questions? Okay, that should hopefully sum up kind of our review on equations, what we've talked about so far. So what we're adding today is, now I want you to write this as a cosine curve as well. Nothing has changed. It's the exact same picture you were just looking at on the last page. If it's the exact same picture we were looking at, A, B, and D will not change. So we already know those, 3, 2, and -2, right? What is going to change is our phase shift, because to write it as a cosine curve, I have to start either at a maximum or a minimum. Well, here's what's going to be challenging about checking our answers. There are 1, 2, 3 maximums and 1, 2, 3 minimums. So there's 6 places up there that you actually could start a correct sine curve in this picture alone, right? Pick one of them. So we pick a max or a minimum. I'm going to pick for us this time to start our graph at. Typically, people pick ones close to the y-axis, so we're not moving super far or whatever. So let's talk about what is that phase shift. Well, sometimes we kind of have to zoom in here a little bit. If we hit a maximum and get back to our midline by that first tick mark, any max or min is going to fall exactly halfway between that, and we got to figure out what half of that first tick mark is. So use your markings on here. If this is pi, what's our first tick mark? Pi over 2, and then to cut that in half would be pi over 4. Okay, so that tells me that we've got a phase shift to the right, pi over 4. Now that is kind of a super important thing, so we're going to stop there. Questions on where I figured out pi over 4?
Wouldn't pi over 4 technically be its origin? Because if that's pi, and then the next full tick mark over is pi over 2, then the next full tick mark would be half of that. Right?
No, it doesn't divide by half each time. Each distance is a pi over 2. So this is 1 pi over 2. This is 2 pi over 2, which simplified to 1 pi. So you're not like dividing in half each line. Each line up here, it's like our scale on our x-axis. Instead of going by 1s, it's going by pi over 2s. Does that make sense? But 2 over 2 simplifies down to 1 pi. Yeah. Other questions? So then writing that into our equation, we're going to start this with this phase shift of pi over 4. Right means it's a positive phase shift, negative in my equation. So amplitude of 3, we're writing it as a cosine because we started at a maximum. We do have a b and a c value, so that means I'm going to need those double parentheses in here. 2 parentheses x minus pi over 4, close my parentheses, down 2. That's what we're adding today, being able to write this as a sine or a cosine with a phase shift. And so you are going to get the freedom to write your equation however you want. So we're going to look at some other options. What?
Tells us where to start?
On the next one I'm going to. Yes, because I want to force a couple things upon us. I picked the next two because of very, very specific reasons. Guys, this is the exact same picture we've already been looking at. Okay, and I picked that so we don't have to think back through A, B, and D. Those are not changing, but I'm forcing a different starting spot on us. Okay, so if I force that new starting spot on us, there's a couple things we need to think through. First of all, based on the starting spot that I have forced on us, what is our phase shift? Yep, pi over 2. Okay. To the right, which means a positive phase shift, negative in my equation. But there's a very specific reason that that's the dot I picked so that we could have this next conversation. Does anyone know why I picked that dot? Oh, back up. I've got one question before that. Are we looking at a sine or a cosine curve? Sine, okay. It's got an it does not. That'll never change. These three are consistent, but it heads down first. So because I forced us to start at this dot, the very first movement this graph makes is to head down. If your sine curve heads down first, it is an ROX. So this would be an example of an ROX for a sine curve. Heads down first from the midline. Midline. Okay. So that means when we go to write our equation, we got to put a negative in front of our amplitude. -3 sine, because of where I made a start, we do have a b and a c value, so double parentheses. 2 parentheses x minus for a movement right, pi over 2, down 2. Okay? Questions on the ROX? Okay, so why? Why would we ever pick a point that has an ROX if I have to remember to put that in there? Well, the reason that you might pick that is if it were to happen to be the one that started at the y-axis, and then you can avoid a phase shift. I always like to avoid phase shifts if I can. So I would pick an ROX over a phase shift if that was an option. but you'll get the option, okay? So last one, exact same picture. I'm forcing you to start at a different spot. So again, we've already done most of the work. A is 3, B is 2, D is -2. So it's a little bit trickier to figure out the phase shift. And then also, again, the very specific reason I picked this one. Right? How are we supposed to figure out that number?
This is where you're telling they are.
Yeah. Okay. What? It is. Okay. It is. Let's talk about how are we supposed to figure out, again, these weird ones that are up there. If you're starting at 0, or if you want to figure out what each of those in-between dots are, if I were to expand this picture of my sine curve, we know that it's going to come out to whatever the period is, right? So whatever that period length is, this is going to be that number divided by 2, right? That's half of that length. So if I were to split that in half and split that in half, that's the original period length divided by 4, right? Would be that first tick mark in a normal graph. And this would be, well, 3 over 4 of that normal period. So let me show you. If this was like a 2 pi divided by 2 is 1 pi. 2 pi divided by 4 is where our normal marking of pi over 2 comes from. Okay? So if this thought process helps you, use that. Maybe it does, maybe it doesn't, but for some of you that might help you figure out that tick mark. It will be the period, half of the period is here, so tick marks in between are going to be the length of the period divided by 4. So if I need to move all the way out to this one, which is what this one is, right? Because this would be, here, this is the length of the period. Need a different color here. Length of the period. There's those 4 tick marks. Period, half the period, right? So 1/4, 2/4, 3/4 of the period, which in our case was pi. So 3 pi over 4. One of the reasons I picked this one was because of the challenging phase shift on that one. The second reason I picked this one is because of, anyone catch it? The ROX, right? If we start at a minimum, that equals an ROX for a cosine curve every time, okay? So writing my equations, I need to remember to put in the ROX to say start at the minimum, our amplitude of 3, cosine, I do have a B and a C value, so we put a double parentheses, 2 parentheses, x minus to say we moved right, 3 pi over 4 minus 2. Questions? Okay. Ignore the use your calculator. I'm going to guide us through how to use our calculators here in just a minute. But what I want you to do is write me the equation of this. This is exactly what your assignment's going to look like. Write me the equation of that in terms of sine and in terms of cosine. How do we attack this? Start with A, B, and D, because that's not going to change, right? One for one of each of your answers. Oh, I don't care which one's which. Yeah. It doesn't matter which order you write them in. So start with your amplitude. Count from the bottom to the top. I'll help you. That's why I said I'll help you. You just start with writing the equations. Oh, you have yours done. Count bottom to top. The first things you should think through. What is the amplitude? Oops. What is the period? What is the B value? Those are not changing for either equation. Okay, my conversation about A and D kind of happened at the same time, right? How far apart are my max and min? Where is the middle of that? So then how far does that make my max from that midline? So distance total from bottom to top would be 4. Half of 4 is 2. 2 above and 2 below. The midline, that is running at -1. So vertical shift is -1, amplitude of 2. I would count this one starting at my y-axis, which is a maximum. So count from a maximum to another maximum. That is the length of the period, right? 2 pi is the period. B value, 2 pi divided by that period. 2 pi divided by 2 pi, 1. Those numbers don't change whether we write this as sine or cosine. Based on where it starts at our y-axis, which one can we write without a phase shift? Sine or cosine? Cosine, right? Because at my y-axis is starting at a maximum. So I could write one of the cosine curves without a phase shift, right? Starting here, I can just write y equals amplitude of 2, cosine of 1x minus 1.
Okay, so I got one.
Sailor. You can do an ROX, absolutely. Yes. So I think there are 2 places that people would have picked to start their sine curve. Not instead of a C. You'll still have a C if you have an ROX. I think the 2 places people would have picked to do a sine curve would be, how many of you picked this dot to start your sine curve? Yeah? Okay. So if this dot is where you picked, you head down first, you needed an ROX. Okay, so if your phase shift was to the right, what is that, pi over 2? You need an ROX. So your equation would have looked like y equals ROX, amplitude of 2, sine, we had a phase shift of right, pi over 2. Oops. Down 1. How many of you picked to start your sine curve here? Okay, if you picked there, you don't because you go up first. You do not have the ROX. So if your C value was negative pi over 2, you should have a positive 2 sitting in front of your sine function and a plus pi over 2 to say move left pi over 2. Always starts at the midline. Okay, so let's check this on our calculators. Here is the biggest thing for the first time this semester. Our calculator needs to be in radian mode. So go to your mode. Go to your mode. Make sure radians is highlighted.
There it is.
Okay, the next thing is this. It really won't look the same unless you set the window to be the same. So we are going to set our window to look exactly like that. All I'm doing is I'm going to type in the equation that I think I wrote correctly into my y equals. And if what comes out on my graph matches the picture I was trying to write the equation for, we did something right. If it doesn't, either I typed it in wrong or I have a wrong number in there. So let's go to our y equals. I picked the most complex. Let's go with that one that had the ROX and the phase shift and everything. I'm going to go with that negative sign, -2, oops, let's try that again, -2 sine of. Now, when you type in sine, it's going to start a parentheses, okay? We don't always need that, but your calculator will, so you'll have to always close that before you do your vertical shift. So I'm doing this one right here, -2 sine of x minus pi over 2. Close my parentheses, and then tell it to move my graph down 1. I'm going to set my window to match what's in this picture. Now, there's a couple things. We, again, have never graphed in a trig function. When you're graphing this, your x-axis went from -2 pi to 2 pi. So in my window, I would do my x minimum from -2 pi. Now, notice, I typed in -2 pi. When I hit enter or arrow to the next line, it'll never leave it in terms of pi. It'll always do the decimal equivalent there, and that's fine. So then 2 pi, again here. And this is the part that'll help you match your picture. The scale means how often did they put the little tick mark on there. Put your scale to be whatever our first tick mark represents. Our first tick mark represents pi over 2. That's the scale. So I would type here pi divided by 2, which again, it'll change into the decimal equivalent. And then my y-axis is normal, -4 up to +2, step by 1. And if I hit enter, it should give me that exact same picture if I wrote the equation correctly. Or graph, I should say, not enter. Okay. Mine is. That is a way you can check. You're like, ooh, I don't think I wrote that sine curve correctly. Go type it in your calculator and see if it gives you the same picture that you were trying to write the equation for. And if your pictures don't look identical, something's wrong. Yeah. No, but if you don't change your window, understand that it might visually throw you off, that you're not sure that they match identically. So I just made mine the same as your picture, so -4 up to 2. Okay, the last thing we need to talk about real quick here, and that's just a way to check yourself. Guys, I'm not going to ask you to do that on a quiz or a test or anything, but as you are getting used to writing your equations this weekend, next week, whatever, that is how you can check your equations to make sure they match. So the last thing is this. Starting Monday, these are used to model real-world things, which we're going to talk more about on Monday, but real world is not pretty. So sometimes we get graphs where the period is hard to figure out because it doesn't end at a nice, pretty, clean tick mark that we have in our picture. So if you notice on this, and it's kind of hard to see the tick marks because there's so much going on in here, but you can kind of follow my grid marks here, that it goes out to 2 pi here. This would be pi. There's my first tick mark of pi over 2. And it starts at 0 at my midline. So I see I'm counting a sine curve. Now if I were to follow that sine curve, hit a maximum, hit a minimum, and get back to my midline, which is supposed to be our method for figuring out the length of the period, I have no idea what that is. Yeah, less than pi over 2 is all I know, right? But it's not half, okay? And we can't guess. So what we need to do, here is your method. You keep counting sine curves until you land at a nice tick mark, okay? So as I follow the next sine curve, which would hit a max, a min, get back to my midline, not a nice place. So follow another one, max, min. That's not a place I know. Max, min, okay, that's a little bit bigger than 3 pi over 2. I don't know what that is. Max, min, this one finally very clearly, you see how that very clearly ends at 2 pi? Okay, so not all of them are going to match this one. Here is what you do generically. The period of this graph is going to equal the nice clean number we ended at. In this case, that was 2 pi. Nice number we ended at. Okay, remind yourself where these random numbers are going to come from. I traced until I ended at a nice number, and in this case that was pi. Divided by how many sine curves it took me to get there. That's why I alternated my colors, so it's easy to see. 1, 2, 3, 4, 5. It took me 5 sine curves to get to 2 pi, which means they each were 2 pi over 5 length. Okay? Now, let's finish this one out. We're writing an equation of this graph. Okay? Well, we don't write the equation using the period. So remember that then to get the b value for your equation, you would take 2 pi divided by the period, which this is the period, right? Okay, so 2 pi divided by 2 pi over 5 is the same thing as 2 pi times 5 over 2 pi, or 5. That's how many full curves we completed by the time we got to 2 pi. Okay, so there's help getting to the equation part of it. But here's the most challenging part of this. I'm asking you to write this as a sine curve, but I'm also asking you to write this as a cosine curve, okay? Sine curve's easy. Phase shift, 0, starts right there at the origin. Cosine curve, what is that phase shift, right? Okay, so here's how you're going to make this a lot easier for yourself. In a sine curve, if we start at 0, the cosine curve starts at the maximum of the sine curve. It would be at whatever that fourth tick mark, or that first tick mark was on our way to drawing that, right? So draw those 4 tick marks, mark it with a period, which we just figured out is 2 pi over 5, and work your way backwards. Okay, well, if this is 2 pi over 5, half of it would be 1 pi over 5, right? And half of 1 pi over 5 would be 1 pi over 10, which means our phase shift is pi over 10. It'll be the first tick mark that you would have used to draw your sine curve.
Oh, I was close.
Okay? Kenzie? Yes, absolutely. Absolutely, yeah. Find another one. That's nice. Sure.
Oh, wait,
If there is one.
no, there's
Yeah.
a minimum that matches up with another minimum.
Yeah.
The second to last minimum on the right.
Yeah, I think that one would probably work. Yeah. Okay. I'll leave that up there. Help you with that. You guys have a worksheet tonight. As soon as I get this out, I will hand out your quiz.